first order linear differential equation. A first order linear differential equation is in the form of dy over dx plus pxy equals to qx. It is solved by determining an integrating factor if, whereby if equals to e, the antiderivative of px dx. Then we multiply the whole equation with if and then solve. Let's start by our first example. So what if I've been given y prime plus y equals to e to t. So this y prime we can write it as dy over dx plus y equals to e to t, and it should be pt, I'm sorry, not dt. So pt equals to 1, the coefficient of this y, and if you've seen is e pt dt. So e antiderivative, we find the integration of 1 dt, so it will be e t. So we multiply the et with the whole equation, so et multiplied by dy over dt plus et multiplied by the y et. So we are left with et dy over dt plus y et equals to e 3t. After that, we, using the product rule, we apply the product rule here, so we are left with d over dt into brackets y e t equals to e 3t. Multiply this side by dt to get rid of it, as well as this other side, so this dt cancels with this dt, so left with dy et equals to e 3t dt. So we integrate this side as well as this other side. We're left with y et equals to a third e 3t plus c. From the previous video that I posted, you will see on how to integrate exponentials and know what I've done here. So we want to be left with y alone. We will divide each side with et, so we're left with y equals to a third e 3t plus c. Divide this by et, divide this side by et, so this et cancels off with this. We are left with e 2t. So the answer will be y equals to a third e 2t plus c over e t. Another example. In given so you have been given this equation and you've been told to solve. First of all, we write t and then dy over dt minus y equals to t squared e negative t. We divide by t, divide by t, and divide by t. So our equation will be left as dy over dt minus y over t equals to t e negative t. This t cancels off with 1t, so it's left with t. So our pt will be negative 1 over t. E integrate 1 over t dt, you'll be left with, which is negative, so it will be negative ln t, which is the same as ln t negative 1, which we can also write it as t negative 1. So this t negative 1, we will multiply it with the whole equation. So it will be dy over dt multiplied by t negative 1 can also be written as 1 over t. So instead of writing t negative 1, we can just write as 1 over t. So multiply by 1 over t minus 1 over t multiplied by 1 over ty equals to e equals to t e negative 1 multiplied by 1 over t. So this t cancels off with this t, so you're left with e power negative t, not negative 1. So it should look like 2 over dt 1 over t minus 1 over t squared y equals to e negative t. So we can also write it as dy over dt into brackets y over t equals to e negative t. So multiply this side by dt as well as this other side. So we are left with dy over t equals to e negative t dt. We integrate and we are left with y over t equals to e, just like that, multiply plus c, multiply by t, multiply by t, multiply by t. So the value of y, so y will be equals to negative t e negative t plus ct. That's our answer. Let's try another one. We have so we will just write dy over dt there plus 2y equals to 40 squared, divide by t, divide by t, divide by t. So dy over dt plus 2y over t equals to 40. So our pt will be equals to 2 over t. E integrate 2 over t dt, whereby we will find that it's e 2 ln t, e ln t squared can also be written as t squared so we take our t squared and multiply to the whole equation. So multiply by d over dt plus 2y over t multiplied by t squared equals to 40 multiplied by the t squared. So we'll be left with t squared dy over dt plus this t cancels off with this, you're left with 1t, so it will be 2yt equals to 4t cubed. We can write it as d over dt yt squared equals to 4t cubed. Get rid of this dt, so it will be d yt squared equals to 4t cubed dt. We integrate this side as well as this other side, so we are left with yt squared equals to t power 4 plus c. So to be left with y alone, to be y equals to t squared plus c t negative 2. Feel free to pause the video as you try the examples. So here our px will be 2 over x. So we find the if, which will be e 2 over x dx will be e 2 ln x squared. That's leaving it as x squared, so we multiply each side with the x squared, so x squared multiplied by dy over dx plus 2y over x multiplied by the x squared equals to 5x squared multiplied by the x squared, so it will be x squared dy over dx plus 2yx equals to 5x power 4. Can write it as d over dx into brackets yx squared equals to 5x power 4 So to be left, want to get rid of that dx, we're left with yx squared equals to 5x dx, so we integrate this side as well as this other side, so you're left with yx squared equals to x fifth plus c. Y therefore will be x cubed plus c over x squared, which can also be written as y equals to x cubed plus c x negative 2. Now on our last example, dy over dx plus y equals to e x. So our px will be equals to 1. Our if will be e, the integral of 1 dx, so it will be e x. So we multiply the if function with the whole equation, ex multiplied by dy over dx plus y ex equals to ex multiplied by ex. Equals to e to x. can write it as d over dx yex equals to e to x. Get rid of this dx, so you're left with yex equals to e to x dx. Integrate, you're left with yex equals to a half e to x plus c. To be left with y alone, you divide each side by you divide each side by the ex, so it will be a half e to x divided by the ex plus c divided by the ex. So our y will be equals to a half ex plus c e negative x.